Hello, my name is Rufus and I'm a technical animator. In this video I'm going to be taking a look at a few examples of connections between controls, joints and those constraints. Now, a large amount of character rigging is really aligning joints and then applying controls in a way that animators might find useful. Maya already has a good amount of constraints built into its toolset, and if you're interested in getting into character rigging, the first stages are generally creating a joint and then constraining them to controls. However, at some point there will be a time where specific constraints such as parent, point or orient will either cause unexpected results or cause a huge amount of slowdown in your rig. So keeping rigs light is really important, and a great way of doing this is by keeping that relationship between a controller and a joint as economic as possible. So you could argue that understanding this relationship between a bone and a controller is a kind of fundamental, and that's what I'm going to take a look at. This video is a dive into setting up various connections. It's also a first look into matrices and how to set them up. So let's take a look at a handful of ways of setting up controls for a joint chain on a character rig. Okay, so let's take a look at what's in the scene. We've got 3 rigs here, all set up pretty much the same. Rig number 2 has a couple of extra nodes in the control hierarchy, but we'll get to that at the right time. But just to quickly take you through this one, we've got a joint chain and we've got the geometry and the controls. And yeah, they're all set up by and large pretty much the same way. So to start off with, if we take the controls and the joints and apply parent constraints in a kind of conventional way, it creates our parent constraints here, and if we take a look at them in the node editor, let's find them here, you can see that if I press 3 to expand them and 3 to expand the joints, you can see how many connections are going on with each individual constraint, and this is fine, but if there are lots of these in your scene, it can really slow things down. So let's delete these constraints and take a look at an alternative way of rigging the arm. So one approach we could make is by minimizing the amount of constraints used. The first control in our joint chain, or our control chain, is the upper arm control. So we can get its offset by assigning a point constraint here and maintaining offset here and applying that. And then from this, you can then make a direct connection between the control and the joint by connecting up the rotation here. So if I select that, you can see that the arm is controlling in a way that you'd expect. Then for the elbow control, can make sure that the rotation is lined up, and the same for the wrist. However, this doesn't give us functionality with translation. So how to get around that? Well, what we have is a value of 24.82 in the translate X. So one possible solution would be to have a plus minus average node, then take this value from the joint and connects up translation into input 0, and then in the attributes editor add a new input and put the value of the joint into the first channel here, the X channel, and then connect up the output of the plus minus average into the translate. And then you've got the elbow not just rotating but also functioning with translate as well. And very quickly doing the same for the wrist. So select the wrist joint, take the translation value, connecting up the controller's translation output to first input, then adding the joint's translation value to the first channel there. It has very similar values to the elbow joint. I don't want that to be confusing, but they're not the same. Anyway, connect those up, and that's one way of rigging an arm with a much more economic setup. So let's expand on that rigging setup in the first rig here. Taking a look at the controls, you can see how they are of a parent-child relationship, and that the all of the hierarchy reflects the same hierarchy as the joint chain, in that they're all children or parents of one another. If we have a look at the second rig here, you can see that the controls are set up slightly differently, and I really don't know what name to give this. You could either call it a tree hierarchy or a flat hierarchy. Call it what you like. But the joints are set up in the same way, in that they are of like a conventional parent-child, but the controls are slightly different. The controls also have like an extra node in their hierarchy, and that extra node is positioned and oriented to the child of the joint that control is the parent of. So just to be completely explicit, if you look at the orientation of this control here, this is aligned to the upper arm control, and the offset joint isn't aligned to the upper arm control. You can see it's aligned to the elbow control, its parent joint. So how do we rig this flat hierarchy in a way that works in the same way as a conventional parent-child hierarchy? Well, the first thing that we're going to do is do the same thing that we did on the previous rig, which is to apply a point constraint to the upper arm control, like that. And then I've got all of the different components laid out in the node editor. I've got the upper arm here with the buffer, the control and the offset here. There's our point constraint. That's the upper arm joint, the lower arm and the wrist joint. Here's the lower arm buffer control, that's the offset, and then the wrist at the bottom here. And I'm just going to realign these so that the offset is lined up with the lower arm, and that the lower arm offset is lined up with the wrist. So just like in the first rig, I'm going to connect up the rotations from the controls. Oh, missed. I'm going to connect up the rotation from the wrist control to the joint like that, and the same with the I see what's going on. The wrist should be down here and the lower arm should be there. Excuse me. Just like that. Okay. And then I'm going to connect up the translation in the same way. It's using a plus minus average, taking the translation of the joint and adding it into our plus minus average node to give it our offset. Plug the lower arm control into the first input and the output into the translation, and if I press Ctrl D to duplicate this, I'm going to do the same with the wrist, but this time take the translation control of the wrist and change that out and plug in the plus minus average into the wrist control. So now we should have the controls set up to work to affect each joint, but because it's flat hierarchy, none of the controls are influencing each other. So to get around that, I'm going to take the offset and create a decompose matrix, and add in the world matrix into the input matrix, and then connect up the translation to the lower arm buffer. And I'm going to do the same again from the lower arm offset to the wrist buffer. I'm going to duplicate this and just do the same set of connections, and we're going to check those results. So now you see that the controls are respecting a hierarchy as far as translation is concerned. As far as rotation goes, we're still getting some unwanted results. So I'm going to take the rotation of the output rotation of the decompose matrix, and plug that into the buffer, same way we did translation. And now you should see that the controls work in the same way as a kind of more conventional hierarchy, but in the outliner they're on the same level. So now we're going to have a look at scaling and setting up some scaling functionality in our rig. The first thing to do is connect up the upper arm control to the upper arm bind joint to make sure that scales, and then we need to make sure that this scaling function propagates through the rig. And in the same way as translation and rotation, I'm going to set up output scale to the scale buffer there, and output scale into the wrist buffer. So let's have a look at those results. Take off this rotation for the time being, and you can see that the controls scale, all the controls scale with the top control, and if we apply the same scale value to the elbow and the wrist, should see that the arm now has this kind of global scaling functionality, which is okay for an initial step, but the controls themselves don't influence the bones. So the elbow control and the wrist control don't provide any scaling influence. So I'm going to take a look at setting that up now. So next up, in order to provide scaling per control, I'm going to break these connections, and then I'm going to take the output scale and create a plus minus average node, and I'm going to change the functionality, the operation of this to subtract, and take the scale value from the lower arm control and add in a new set of values. So this is now subtracting scale from itself. Then I'm going to create another multiply divide node, and it's shot up all the way over there. I press Ctrl D to duplicate it, and going to connect the output of this plus minus average node, which is set to subtract, and I'm going to change this to sum. Then I'm going to take the upper arm control and take that scale value, and then as this is getting its values from the lower arm control, I'm going to connect this up to the lower arm bind joint like that. I think I need to reconnect the upper arm control to the upper arm bind joint, and then I need to do the same for the wrist control as well. So I'm going to take these two plus minus average nodes, press Ctrl D to duplicate them, and they've both shot off up there, which is really useful, but oh well. And this one is the subtract node, so I'm going to take the scale output from the left wrist control, put that into the first channel, and then connect the output of this into the sum operation one, and connect this up to the wrist joint scale value. And now you should have scaling from here as well as scaling from here and scaling from here. Unfortunately, I haven't actually set up the fingers, so what you're seeing is the weighting around the wrist scale, but the fingers are weighted to the finger joints. But anyway, that's that gives you a kind of idea of how to kind of add in per control scaling functionality. And earlier I said that this was global scaling, and it's really not. The scaling is coming from the upper arm control, but that doesn't mean you can't create a global scale function and have that as a separate attribute that that can be threaded in to these plus minus average nodes, and then set up the upper arm control to behave the same way as the lower arm and the wrist. So that's like that's another kind of potential way of setting up scaling for your rig. So in the first couple of examples, I used a point constraint to constrain the first joint, the upper arm joint, to its control. And this time in the third example, I'm not going to use any constraints at all. It's all going to be done with matrices. And I should also add that the controls are back to a conventional hierarchy rather than the flat hierarchy I had in the second rig here. So if I open up the node editor, we've got the controls for the rig here, and here I've got the joints. I've also got the clavicle joint included because the equation that I'm going to use is going to be the world matrix of the control plus the world inverse matrix of the parent of the joint, and that will give us the parent offset of the joint that we want to control. So how do I express that in the node editor? Well, we need a multiplication function, which is mult matrix, and then I'm going to plug in the world matrix of the upper arm joint, and then take the world inverse matrix of the parent of the joint that we want, and then attach the output of the mult matrix into the offset parent node, like that. And let's take a look at what that's given us. Okay, so the matrix is now hooked up, but the joint now has offsets which aren't any use to us. So if I zero out the translation of the joint and the joint orient, we now get the bone to where we want it to be. And if I test the translation and the rotation, there's a good functionality there. So I'm going to hook the rest of those up. If I press Ctrl D to duplicate it, then do the same again. If I take the lower arm or the elbow control and attach that to the first matrix in channel, and then from the parent of the elbow joint, which will be the upper arm joint, select the world inverse matrix and attach that to the second input, and then connect this up to offset parent matrix, and I'm going to do the same for the wrist, which is take the world inverse matrix and the parent of the wrist, which would be the elbow, and attach that one into the second channel, and then input the offset parent matrix with the output from this matrix here, with this multiplication matrix. So as you can see, we've got some offsets that in this setup aren't of any use to us, so I'm going to zero these out, and same again for the wrist. And you can see now we've got the joints back to where we want them, and they all seem to be working pretty well. and going to try scale now. And if you notice that this way of applying matrices affects scaling in a different way. In this one we just applied it. Oh, it's not hooked up anymore. In this previous version we just applied it and it only affected the wrist, and in this one it now it affects the wrist and all the children, so scaling behaves in a different way. Another thing to point out is that if, excuse me, I think I just set that to 0 instead of 1. Another thing to point out is that we had to zero out the transforms from our joints and the joint orientations. So if this were going to be an FK joint chain controlling your bind joints, then there would need to be an extra step between what this joint is now doing, because we've changed its orientation and the values of its orientation and changed the values of its translation. But because that's kind of a kind of next step along, it's not kind of explicitly to do with how the controls in this tutorial relate to the joints. So that's for something further down the road. So there are 3 different setups here, and they've all involved different ways of constraining controls or setting up controls to drive joints in different ways. And I don't think there's any real wrong way or right way of doing things. However, getting things done quickly as a character rigger is always a constant, especially in a professional environment. So in my mind, it's whatever gets you over the line soonest. That's the most important factor. And yeah, there can be bugs and there can be unexpected results, but in a professional sense, getting prototypes to animators as quickly as possible is the underlying factor. All of these are worth experimenting with and making sure that you know what works and what doesn't. Okay, cheers.